Good afternoon, and thank you so much first to Henry, your students, and the rest of the faculty at CCAT. It's such a pleasure to be here. The work you're doing here is really transformational and important, so thank you very much. Henry's already introduced me, but just a little bit about me. I've really spent the last decade of my career focused on autonomous vehicles and autonomous systems at Waymo and at Apple. I've got a thread of robotics that runs through my blood deep from the time at NASA until now, where I'm really working at Cavenu to enable autonomous vehicles and autonomous technology, connected technology, to scale as quickly as possible so that everybody can have that important technology. That technology is super important to me for a personal reason. This is my dad. His name is Doug. And my dad is a proud Dutch farmer in Bozeman, Montana. And my dad is the kind of man who loves to get in the car and drive. He doesn't want to fly anywhere. He lives out in a rural part of the state. And if you need to go to the grocery store, you drive 15 minutes into town. If you need to go to the doctor's office, it's 30 minutes into town. And he is a person who just loves to be in a car and loves to get where he's going, and he's always got somewhere to be. About 3 years ago, my dad was diagnosed with Parkinson's disease. And if you know Parkinson's disease, and I hope you don't, but it's a terrible disease, and one that really erodes your ability to move. And so I've watched my dad as this disease has onset, and I'm watching the day coming when he's going to lose his driver's license, and he's going to lose the ability to get where he wants to go. And in Montana, that's important. You don't just call an Uber to get from A to B. And what I've really come to realize is mobility is not a luxury. Mobility is a fundamental human need. And I think the pandemic has shown us very, very clearly that we need connection in our lives. We need the ability to get out and about, to get to the grocery store, to get to our jobs, and to get to see our friends and our family. In 3D is so much better than in 2D. And so mobility has become my life's work. Not just for my dad, though I love him, but for everybody. There are millions and millions like him who don't have access to mobility currently in the United States. So that's why I think autonomous vehicles and autonomous vehicle technology is so, so important. I think it can make the roads safer. I think it can give people really important time back, and I think it allows everybody to have access to move from A to B. And billions of dollars are going into capital, are going into autonomous vehicles. About $80 billion has already been spent in the research going into these kinds of vehicles. And I tried to pick ones that are local to Michigan here, but there are tons. There's about 27 companies that I know of that are building autonomous vehicles right now in the United States, working on this very important problem. And I think Waymo's really been at the frontier of that. I'm so proud of the work that we did there and that they continue to do, that really is figuring out, like, is this even possible? And I think Waymo is clearly showing it's possible. There's a driverless service that's going on right now in Phoenix, Arizona. Cruise has done some incredible things with early testing in San Francisco that's driverless. You've got Tesla that's running full self-driving software in their vehicles right now, and you can buy those vehicles. And you've got Argo just up the road that's just launched today, an announcement that they're doing goods delivery in partnership with Ford and Walmart. So the industry is absolutely making progress, but those are very incremental steps that are making progress. When you look at a map of where people drive, this is where you would put an autonomous vehicle service if left to what we want to do to make money. And let's face it, in business, you want to make money. And so you focus on all of those blue dots, and that's where you would probably put the self-driving vehicles first, because that's where people want to drive. You can see my dad lives in the middle of the kind of place where people don't drive and people don't live. There's about 1 million people who live in the entire state of Montana, and the state is larger than the state of Michigan. So there's just not a lot of people there. There's not a lot of incentive to make that autonomous vehicle technology work when you're really trying to solve a lot of different scenarios and how you make vehicles drive. And by the way, even on this map, there's only one place on the map that's got driverless cars running regularly today, and that's in Phoenix, Arizona, due to Waymo. So why is that? Why is it that we would pick one place? We've got billions that are going into research in autonomous vehicles, but there's really only one company who's regularly doing that driverless drive on public roads. It's because autonomous vehicles are hard. And one of the big reasons they're hard is because the world is nearly infinite that you have to design that robot to drive in. You can look at the environment. You've got all the different weather. You've got different lighting conditions, whether it's from the sun or it's from driving under a tree-covered road where you've got that dappled light, or you're driving in and out of bridges. Cameras hate that. Cameras hate that drastic light change that's happening. And so you're trying to train a robot to deal with all of those kinds of scenarios. And then you add the road conditions in, whether it's the potholes that many of you know and love in Michigan, or it's the snow, the ice, the standing water when the roads flood. All of those things create hard conditions for a vehicle to know, is that a puddle that I can drive through, or is that a flooded road? How's the vehicle going to know that? So there's so many hard things just in the weather. Then you look at the road configuration, and our roads today are nearly infinite in all of the different geometries and different permutations that you can put together with the angles of the ramps, the interchanges, the bridges, tunnels. And you can read the list here. I'm sure it is not complete. But the road system that we have in the United States is very complex. And then we've got all the different actors that can be on the road, and whether they're pedestrians and vulnerable road users, whether they're static objects or dynamic objects or animals or other vehicles, emergency vehicles. They all have different rules on how you engage with them, and they all have different ways that they can move about. And so you have to be able to train a vehicle to deal with all of those situations. And then all of those actors are all doing their own maneuvers, and they're all influenced by what the other actors on the road are doing. And sometimes those actors are influenced by other actors. So you've got first, second, and third order interactions that are happening on a road with a significant amount of actors that can do different things on different road types in different environmental conditions. And so when you figure out all of those permutations, you've got a nearly infinite problem that you're trying to solve. So what do we do about it? Well, let's first look at how some of the best in the industry, some of the tricky situations that they're dealing with. So this is a product you can buy today, and hopefully it's going to work. And you can see it's pulling up to this traffic light. It doesn't understand the semantics of the paint on the line, painted lines on the road, and so it literally pulls in behind a parked car and gets stuck because it doesn't understand those scene semantics. Here's another one. This is one of my favorite ones from my time at a previous employer. Car pulls around the corner, and you can see up in the top image, there's a woman in a wheelchair that's chasing a duck. She's got a broom in her hand. And when would you ever think to train a robot for a situation where there's going to be somebody chasing a duck on the road? And it's things like that that come up day in and day out when you're driving millions and millions of miles, and you have to be able to take care of all of those corner cases. So let's look at a few more scenes that came out of our work. When you drive around Google a lot, there's a lot of employees that like to play Frogger around the vehicles. I do not recommend this. Please be safe. This is an interesting one. There's not one, not two, but wait for it, 3 vehicles that all go the wrong way down the road in one intersection. This is one where a gentleman decides to give the car a hug because, we should hug cars as we pass in front of them. And this is a man who was so excited to see the self-driving car that he came out naked and danced in front of the car and then communicated Top Gun style. So I'm trying to illustrate through some funny situations and scenarios that this is a really long tail problem. And not only is the world complicated and complex in its own, and there's nearly this infinite set of permutations to deal with just in basic driving, but then you look at the other vector, which is the safety scenarios, and how do you deal with all of the different rare cases where you can't get data and you can't necessarily think of everything that could happen to be able to train a machine learned model, yet somehow you have to have a robot driver that can deal with it. And so, you would never think that you could have a significant data set, for example, of a woman in a wheelchair chasing a duck down the road, yet you've got to have a robot that when it sees that scene knows how to generalize the algorithms well enough to be able to handle that situation. And I've shown you just a couple of those long tail scenarios and how you have to be able to understand the semantics of the world around you, even if you've never seen it before. And we as humans are pretty good at that, but to train a robot to do that's actually really hard. And so at Cavenu, we decided to try to think different and allow the robots to cheat. And so how can we remove the long tail? And I think that the way you remove the long tail, at least our thesis at Cavenu, is that you do it by letting other parts of the technology around the environment and the ecosystem do part of the hard lifting for you. So at Cavenu, we simplify and enhance the driving environment, and we do that to deliver that hands-off, eyes-off automated experience and enable the safer and more efficient roads. And so I want to draw your eye to a couple of things. The first thing I want you to see is the sensors on top of the pole in the middle of the image. And that's a sensor pod that we have that gets the benefit of sitting and staring at the same scene day in and day out. And what that means is what's typically on a moving vehicle in a moving scene, that the vehicle now has to try to figure out dynamically what's going on. Now you can put it on top of a pole and it gets the chance to what we call loiter. So it's just sitting there and all it has to do at that point is measure differences. I looked at this scene, all of a sudden there's a car here that it doesn't seem to be moving. I should flag that there's a car parked here now. And so there's lots of simple things that when the sensor pod gets to loiter, that simplify the world. We communicate to the vehicle through a couple of different methods. One of the methods that you see here is the sign. That's to enable the benefits of Cavenu and the simplified environment that we're creating to not only connected vehicles, but to human-driven vehicles. So we can provide those insights about what's going on the road up ahead, not only through Vida-I kinds of technologies, but also through written communication that will allow our vehicles of all types and makes and models to benefit from the throughput efficiencies, reducing greenhouse gases, and the safety benefits that we can provide. We also think a lot about transit at at Cavenu. I just showed you so many Waymo videos, I'm confused. We think a lot about transportation and transit and how do you create nice connected corridors that get people where they want to go, connect the jobs to the people, connect the education to the people. And so we build a lot around how do we make the right corridors and how do we connect them so that people are getting what they want. In the bottom left, you see somebody who's in that connected vehicle who's getting that full hands-off, eyes-off experience and is really enjoying the benefit of not having to drive and getting to do whatever they want. That vehicle can now become a third space where it can be your office if you want to work. It can become your dining room if you want to have dinner. It can become a place where you play games with your kids as you're commuting from A to B, whatever it is. And then the last thing I want to draw you to is right here. One of the things that I think is really important to simplify the driving environment is just to create that lane where you know what's coming in and out of the lane, and you know when they're coming in and out, because there's a barrier there that helps just break the driving from the general purpose lanes. So let's talk a little bit more about how it works. I realize that I'm talking to a bunch of engineers, so I want to nerd out for a minute. So our technology stack really enhances what's already on board with the vehicle. And so it's really the technology that's on the road and connecting to the vehicles that can enhance what the vehicles are doing now in partnership. And so one of the things we do is that ODD, which is the operational design domain. That's how we simplify and standardize the roads. And so a thing that we do when we come in and we design the lane of the future is we make it much simpler to merge in and merge off. The intersections become easier to deal with because we're just going to clean up the road design wherever possible. And we make the world more predictable, because the world starts to look the same. You remove a bunch of the variations and permutations that can happen. You create that separated lane. You create, consistency on how vehicles get in and out of that lane. But I think the most important thing is we want to work with DOTs and DMVs across the country to standardize the rules of the road. And right now, one of the really hard problems is that when you drive in California, the rules of the road are different than when you drive in Michigan. So for example, if you want to turn right across a bicycle lane, in some states, the right thing to do is to stay out of the bicycle lane and turn right around it. And in some states, the right thing to do is to move into the bicycle lane and then turn around it. But depending on what state you're in, you need to do something different. And it really matters, because there's human bicyclists in that lane that are counting on you doing the right thing, because they probably live there and they expect all the drivers to behave the same. And so it's nuances like that where the laws change and they're different from state to state, and they're changing within the state from year to year, that we think Cavenu can really help with standardization. The next thing that can happen is that we can enhance the environment that you're driving in through network self-reporting. And so right now, a self-driving car can see about 200 meters, depending on the technology that they've got on board. But when you're in a Cavenu lane, we can see miles and miles down the road. So we can tell you what's going on well up ahead, similar to Waze, right? Where Waze is like, look, there's a police officer up ahead, there's a hazard up ahead. Well, now Cavenu can tell you there's ice on the road up ahead. You should slow down. Or there's a big pothole, you're going to want to try to nudge to the left-hand side of the lane. And then we can provide that driving guidance. So based on what we see, we can recommend a speed for you. We can recommend what part of the lane for you. We can recommend a following distance from the vehicle in front of you. So now, if we can start to get collections of connected vehicles, we can start to think about the efficiencies that can happen with platooning and some of the other technologies that I think are really important for throughput and for reduction in greenhouse gases. And then the last thing that we really focus on is a reliable ground truth data source. So one of the things that's really important for us is that we want to provide data for synchronous fleet and vehicle actions. When one vehicle sees something, we communicate it to everybody else around so that they're all working together in concert to make the most efficient driving for everybody who's on the road at that moment. And then the last piece, which is so important and so hard, is right now, self-driving cars are very dependent on the map in most companies, not all, but in most companies, knowing where the stop signs are, knowing where the stop lights are, knowing where the lane lines and the curbs and the parking spaces are, all of that's very important. You saw that first video, that car clearly doesn't know that that part of the map is a parking spot. So one of the things that Cavenu can do, because we stare at the road all day, we can tell you where are the lane lines, we can tell you where the parking spots are, we can tell you which direction traffic is going. If there's construction today and there's a temporary stop sign or a temporary speed sign, we can report all of that to you. And we can make the operations of the road just more and more efficient. Let's double click. Okay, this one is an eye chart, and I always hesitate to do eye charts when I'm doing a big talk, but I really wanted, because I'm at the University of Michigan and you're such respected faculty, I really wanted to show you under the hood of what we're doing. And so I want to draw your eye to a couple of loops here. The first loop is this vehicles through sensors to the digital twin to the communication devices. That loop right there. That's a super important loop and one that we really think a lot about, which is you've got the vehicles on the road. We've got sensors that are sensing and seeing what's going on the road. Those sensors are tied to edge compute that are calculating on the edge what's going on with algorithms and making insights and recommendations. And it's connected to a digital twin. So that's the edge digital twin. It's connected to a cloud digital twin that can do more of the asynchronous work. So thinking about things like overall speeds and feeds for a road operator that has a tolling lane as an example, then they can figure out their managed lane dynamic pricing. And so that's an important, and that all goes back to transceivers and digital signs that can communicate with the drivers both near real time from the edge cloud and from asynchronously with the cloud, the basic cloud digital twin. Any recommendations on how to mitigate the things that are going on the road. And sometimes those go straight to the drivers. Sometimes that communication actually goes to the traffic management or asset management people. The other loop I want to draw your eye to is down here. The physical ODD simplification enhancement and back to the vehicles. And that's the one that you know is easier to show in the images that I've shown you, where you're really focusing on putting on a barrier and separating that lane when you need to. So we call it an on-demand barrier. We partition that lane when we want to run in a full hands-off, eyes-off mode. Different lighting. I think improving the lighting within the lane to make it more consistent so you're not dealing with that mixed light condition, or at different intersections. You know how you pull up to an intersection and it's late in the day, you're coming home from work and you're kind of going like this because you can't see if the light's red or not red? What if the light just said, I'm red and I'm going to be red for 5, 4, 3, 2, 1, right? So easy to do. Like that technology is a $10 part. And so we can do things like that very easily, integrate it all together through one connected system. And then the last piece is the other physical infrastructure pieces where we simplify that road design like I talked about. So this loop, super important to make the driving environment easier and solve that part of the ODD and really connect the rules of the road and self-report the map. And then this loop up here to give you the insights on what's going on more dynamically on the road. So let's double click in through a couple of images and talk about what's easy and hard and how Cavenu can help. So in this image, it's a snowy day. Imagine you're going down Michigan Avenue, which is a street we know and love because of our Connected Corridor project. And it's a little hard to tell if the light is green or not. And this cyclist sure feels pretty close to the self-driving car right here in the left-hand lane. And so this is a challenging but kind of basic scenario for a self-driving car. Cavenu comes in and we can simplify the lane by saying like, look, the bicyclist should not be there. Let's put the bicyclist in the bike lane. So we can do some simple road construction, add a barrier to separate the lane so that that connected vehicle is now in its own lane. And we can tell you the crosswalk is clear, so whether there's an occlusion or not, you'll know that it's okay to cross that crosswalk because no one's in it. We can tell you, you probably didn't notice this in the last image, but there's some black ice right there. So we can tell you there's black ice up ahead. We've observed the road. We know that it's there. And you should really reduce your speed to 15 miles an hour to safely cross that black ice. And we can tell you the light state. The light's green. And we can tell you how long it's going to be green for. And then in an ideal world, we can optimize the timing of the lights based on the dynamic conditions of the road today, which would be amazing. Here's another scene. This one is a vehicle is cutting off ego right here. I don't know if you can tell, but there's also a pedestrian in the crosswalk that's semi-occluded by that vehicle. And that's a really hard problem. Occlusions are really hard for self-driving cars because they can't infer things very well. They're getting better and better at it, totally, but it's a hard problem. It's hard for us as humans. And then there's an emergency vehicle. And so understanding that that emergency vehicle is there and what you're supposed to do in that case. So again, we simplify, we put that barrier up, give you your own dedicated lane. That removes the ability for the vehicle to cut in. We also tell you the crosswalk is occupied. So whether you've seen this person as they're crossing around this car, which is a hard thing to see, humans, honestly, the way they do it is they look through this car's windows often to be able to see that pedestrian. And we tell you there's an emergency vehicle that's coming, so you need to stop even though the light is green. So we add a lot of benefit, and we think about 4 key stakeholders as we design our products at Cavenu. The first one is the traveling public. And across America, the average American spends about 1 hour per day commuting and wastes about 100 hours per year in traffic jams. And so they don't, that's not the enjoyable part of driving. And I've had a lot of conversations through my time in autonomous vehicles where people are like, but I want the joy of driving. And I'm like, yes, the joy of driving for us in California is driving along Highway 1 along the beach. It's stunning and beautiful. The joy of driving is not driving Highway 101 during rush hour and sitting in traffic. And so we're really focused on let's allow you to have your preferences and allow you to have choice in how you get from A to B. The traveling public also wants equitable access. 30% of Americans who are of age to have a driver's license do not have one. They don't have access to mobility on their own. And that's not to mention children who are too young, the elderly who have aged out of the ability to drive. And so that's a big portion of Americans. In addition, if you look at unemployment, the #1 reason that people list that they are unemployed is access to transportation. It's 70%. So we need to give people this access. DOTs and policymakers want to save lives. During COVID in 2020, traffic fatalities per vehicle mile traveled went up by 24%. That's huge. And most of that is because the roads were actually more wide open, so people could drive faster, and thus the energy and the impacts was higher. Policymakers also want increased throughput. Congestion in major metropolitan cities has doubled in the last 30 years. So I talked to lots of people who were like, man, when I lived in Bozeman, it was amazing, like you could get anywhere. And now you go to town and you just sit at the light for 5, 6, 7 lights because there's so many people in town. And that's my hometown, which is not a major metropolitan area, but it is a pretty amazing place to live. And so I think we've got to figure out how to get people where they want to go without adding more vehicles to the road. By increasing the efficiency of how people are moving. They also want to meet their environmental goals. If we can create an infrastructure that can enable EVs even more, electric vehicles, they can decrease the average lifetime emissions by up to 70%. The other thing that we can do to reduce greenhouse gases, even with typical ICE engines, is we can optimize the average speed of the lane. so that people aren't accelerating and decelerating. And where you spend most of the energy and the most of the gas consumption in a vehicle, it's from slowing down and then speeding up. And so if we can get everybody to an average speed, then that'll be really, really good for emissions. Our road operators want to prevent leakage. Right now, there's not a lot of managed lanes in the United States. It's a fairly small number. But of those managed lanes, they're losing up to 30 million annually due to revenue leakage. People weaving around the toll gates, which is so dangerous. And they want operational efficiencies. They lose more than $90 million in value annually due to things like having to have human QA because the machines and the technology that they have isn't working correctly. There was just a big story about this with tolling in San Francisco. OEMs and AV companies, where I come out of, really want to ship, and they want to ship at scale. And like I told you already, the industry has spent over $80 billion without a clear timeline to ROI. And I think that that's because you don't know how to solve the long tail problem. So what vehicles work in our lanes? Any vehicle that is what is called an SAE language, a level 2 autonomous vehicle or more. So the big hope and vision of Cavenu is that you can take a vehicle that has typical adaptive cruise control and lane keep assist, which most modern cars have, and with that experience, the simplified lane, the added vision all the way down the road corridor, you can now have a self-driving vehicle. And that means Cavenu is working in concert with a lot of OEM partners to make sure that we're building something that's going to work for us. And a lot of people ask me, what does that mean? Like, how many vehicles does that actually mean? There's many Cavenu capable vehicles that are on market today. Cruise has a vehicle with General Motors called Super Cruise, and it's in a couple of vehicles already, and planned to be 22 models by 2023. Ford has the Mach-E Autopilot with Blue Cruise, and it's in the Mustang Mach-E and the F-150 Super Cruise already, and it's coming out to more vehicles as quickly as they can get it out. Tesla's running Autopilot, Volvo's got Pilot Assist. Again, those are things that are already out on market today and being added to more and more makes and models. So it's not science fiction, it's not technology that's not shipping, it's shipping and it's happening right now. And so I'm really excited that this is a great way to start scaling. So I will close with a video on the vision of Cavenu. And apparently we've got audio.
At Cavenu, we are building the world's most advanced roads. Cavenues are dedicated lanes that enhance connected and autonomous transportation, making travel faster, safer, and more accessible. Our infrastructure will enable vehicles to talk to each other. Cavenu will improve how vehicles collectively perceive and react to their environment. Cavenues optimize public transit with the efficiency of dedicated corridors, letting you travel safely, quickly, and autonomously. Cavenu, building the future of roads.
So I hope you can see there's lots of interesting problems to work on in this space. Some that I'm really personally excited about is how do you virtually represent the real world? Like, what does it look like when you have a digital copy of the road? And what are the different use cases that come out of that, the different product applications from that? Whether it's tying into a maps application or it is communicating into the infotainment system, helping road operators, helping transit and goods delivery. There's so many applications there that can be really amazing. Like I said, you've got that long tail of driving. Cavenu hopes to think differently by enabling the infrastructure to help connect to the vehicles and tell them more about what's going on so that the vehicle doesn't have to handle that long tail. We've got to understand what's in there to make sure that the infrastructure is mitigating the right things. And that's a pretty fun problem. The infrastructure infrastructure to vehicle, what are the communication standards we want to use, what are the latency standards, and how do we get that commonized across the industry? What information are we communicating, at what frequency, at what latency? Those are big topics that we work on a lot at Cavenu. The cybersecurity pieces, obviously there's a lot in that topic, and just making sure that everything is really robust. All of the different safety, quality, and comfort benefits that can come from an enhanced infrastructure and the road of the future, and how do we want to deliver that, and what features are we prioritizing, and when are those rolling out, is a problem that I spend a lot of time on, and it's super cool. And then I think we need novel sensing modalities. I think LiDAR is expensive, and LiDAR is hard to maintain. Radar has its day and has its kind of application. Cameras are a great sensor, but what could microphones do for us? What could thermal imagers do for us? And how do we fuse those technologies together? And like, what's the right application? So we spend a lot of time working on that internally and with partners. So with that, I close. I am really happy to take questions. And again, thank you so much for having me today. Such a small room.
Yeah. Well, it's a small room, but there's a lot of questions for you.
Oh, great.
Amy. One of the questions I have, and I really like the idea, and I agree with you in terms of this reducing ODD by really simplifying the driving environment, essentially. And that also, you mentioned some of the instrumentation on the roadside,
Yep.
and then can observe in terms of the driving environment, and can essentially warn the drivers or warn the autonomous vehicle ahead
Yep.
of the game. Then one of the questions that people always ask, who is going to pay for all that? It's road infrastructure need. If you need investment on these road infrastructure, then who is going to pay for that, and who is going to maintain that?
Yep.
And what are the financial model that, and Cavenu is thinking to essentially make this work?
Yeah, it's a great question. In general, and I don't want to release all of our secret ideas about how to do it, but in general, the plan is that Cavenu pays. And so there's ways that you can do project financing. There's ways that you can work with the federal government and the DOTs who are trying to figure out how to add roads of the future and modernize. The Biden infrastructure bill is making its way through Congress, and there's a lot in there about trying to modernize the road system. And so there's a lot of different revenue sources that can really pay for that. But in general, our vision is that we can help with that, because then we can have access to that lane and make the money off of owning and operating that lane. Who operates that lane and maintains that? There's a couple of different ways that it can be done, and it really, I think, is going to depend on which state, which project. I think that there are cases where, for example, a road operator that already has a managed lane but really wants to modernize it and enable the preference of a hands-off, eyes-off experience, they may want to continue operating that lane, which is great with us. I think there's other models where the state wants to continue to operate the lane, and that can work totally fine with us. And there may be models where they're asking us to do it, and we figure out if we're going to do it or partner with somebody else who's great at that. So there's a bunch of models that we can go after in that front.
Yeah, I always think in the future, a new type of companies, what I call intelligent transportation data providers, or something like that, may emerge and to provide critical information to automated vehicles to basically share the load of, whether it's computational, whether that's for perception or whatever it is.
Totally.
So I think Cavenu is, in my mind, is one of these pioneers that might be one of these, I would say, intelligent ITS data service providers.
I think that there's a beautiful thing that you've hit on, which is when we basically put a perception system and edge compute along the roadside and we connect to the vehicle, that can actually offload what has to be on board the vehicle, which can make those vehicles, you know, a lower price point and more accessible, or make it a kit that can go on buses and trucks for long haul trucking and good transportation, or vehicle or human transportation. And so I think that it can actually make those autonomous services something that's reasonable and within reach.
Yeah, I asked my question, and then there's a number of questions here from the audience, and
Great.
So there's a question. This is one of the interesting questions. The question is, indeed, lots of or billions of dollars are spent on bringing robot taxi to the general public. With Cavenue's new approach, and do you have idea how many more billions will be spent before your dad can finally experience robot taxi where he lives? Which company, Waymo or your company, Cavenu, will bring it to him first?
You know, I actually, I don't know how many more billions are going to go into it. I'm thankful that there's a lot of companies that have money to invest in this technology, because I think it's a really important one. And I'm excited to see everybody that's really working on the problem. A company that we didn't mention that I think really does focus on Bozeman, Montana is Aurora. Because they've got offices there.
Okay.
And you know, I think that there's just so many companies like that that like we don't talk about necessarily, but could be the one that does it. And so, you know, maybe it's Aurora because they're in Bozeman. Maybe it's Waymo because they're already driverless. Maybe it's somebody we haven't even heard of yet. Like, I think Pony.ai is doing incredible things. And maybe they're the ones that just figure out that next breakthrough and how it connects in with Cavenu. My goal at Cavenu is to really make sure that we're building the technology that can expand and scale to as many roads as possible, as quickly as possible, with that goal of, by the time Dad loses his driver's license, there's a Cavenu and an AV partner that are right there to give him what he needs.
It's great. So there's this question. I actually, when I saw your picture, I have that question too.
Yeah.
What ideas does Cavenu have to manage snow in the dedicated lane? We're living in Michigan, and so you have dedicated lane, and particularly if you have lane barriers, and you know, it might create difficulty for snowplows.
That's correct. That's one of the first things that, like, when I came in, I was like, yeah, we need a barrier. And then everybody's like, you got to plow snow. And I'm like, oh yeah, I've been in California too long. And so one of the first things we did is we really committed to what we call barrier on demand. But that's a barrier that can be removed from the road so that you can plow the road, and then it can be re-put down very, very easily. There's a couple of technologies that already exist that do that. There's one on the Golden Gate Bridge that moves the barrier from one lane to the other many times a day if it needs to. And so there's lots of different ways that we could solve that problem.
So there's this question is also related with dedicated lane. How does it work if I'm not in the dedicated lane, but I want to make a left lane change across it?
Yeah, that's a great question. That's one that happens when you start coming into urban settings where you've got intersections. And I'll be transparent, we haven't done the lane design on that intersection yet. There's a couple ways we think about it. One is, you know, that there's dedicated rights-of-way. One is similar to what you see today, that you put a brake in it, you run an unprotected left around that lane. And so it just becomes, you know, part of what you're turning around. But I think that there's a lot of lane design to happen before we would have a real concrete answer for that. And if folks are on the call that want to come help us do lane design, like, we need help.
Actually see announcement from your company that you're hiring highway engineer. He's a highway design engineer.
Yep. We're hiring about every role there is right now. We're growing very quickly, so.
Okay. And there's another question is, you talk some of these harmonizing state road regulations.
Yeah.
And have you identified the first regulation that you would address?
Well, we're starting with our Michigan project, and so I think that the first regs that will pop out are as we start looking at the second state and third state to deploy, where are the commonalities and where are the differences, and then that'll make the prioritized list for us. So I wouldn't say we have it today. I can tell you from an AV perspective, my experience for the last several years, that the example I gave you of bike lanes is a really tricky one. That just, it moves from city to city and things like that just make it really hard, not just for the robots, but for the human drivers as well. And so I think a thing to just remember is when you're simplifying the road and making the road safer and easier to drive in, it benefits everybody. And I think that's just so important, because we've got the fatalities, like I said, going up by 27% last year, yet we're not working on simplifying the roads. We're trying to add more and more technology to the vehicles. And I think both need to happen. And so I think that Cavenu is a place where we can do that and really provide that benefit for everybody who's using the roads.
This is the next question is coming from one of our faculty members. And she said, "This very interesting talk and thank you." And her question is that, how can individual faculty or research group be involved in the Cavenu projects?
Oh, yes, please. Please, like, let's talk. I'll give you my number and we'll figure it out. You know, I mean, I think right now, like I said, we're hiring basically any position you can think of. We also are looking for projects that we could do with universities. I think there's a lot of places where we're going to have great data, and there's a lot of research opportunities there. So I would just say, you know, reach out. The thing that's interesting to us is when we can start to get dedicated research projects that are clearly defined, and then we can make progress on them together.
Excellent, excellent. There's also an interesting question, this question related with, in the 90s, there's, you know, in California, there's automated highway system being developed and being demonstrated in, I believe it's in 97, which at the time is also promised for sort of dedicated lane for automated vehicles at the time. And the question is, I believe some of the the question is, the question from the people who asked this question, I believe some highway message board began to appear back then, and congestion ahead and such, and the hype of this type of effort has been seems disappearing or being reduced in the last 20, 30 years. But recently, with autonomous vehicles, it shows, you know, it's actually reappeared and getting more attention now. And so the question is, what changed, and why you confident this time will be different?
Yeah, you know, the idea of autonomous vehicles isn't new, and the idea of smart infrastructure is not new. There's a 1950s ad, I think, from General Electric, where they paint a stripe down the road and they've got the vehicle and everybody's sitting around a chessboard. Yeah. Most of us that are transportation nerds probably know this picture well. What makes it different this time? I think that what makes it different is the country is hungry for an improved infrastructure. The roads are really congested. The safety issues are going up, not down. And so we've got a lot of data that we're looking at right now that says something has to change. And we've got so many people across all of the stakeholders that are all pushing for this change. And so I think that there's real alignment, that there's a problem. There's data that supports it now. And I think that there's a lot of push from companies who have a lot of capital and companies who have a lot of willingness to partner to be able to come together to do it. And I think that the key thing for a project like us to be successful is that you've got to be able to sit at the intersection of technology, auto and AV, and infrastructure. And you've got to be able to understand those three different worlds, and you've got to be able to integrate solutions that speak into those different industries. And I think that that's what went wrong last time. And I think that if you look at the team that Cavenu has put together, we've got world-class leaders in all of those domains.
Excellent, excellent. This is one of the questions I think that sort of related to some of the things we talked about previously. Who will repair and maintain these future high-tech infrastructure, and where will these future technicians to get necessary training? And everything breaks. And that's from this question.
Well, if everything breaks, then there's a lot of people who didn't do their job. That said, everything needs repair, right? Like we talked about earlier, there's a couple of different models for who is operating those roads. The same models apply for who's repairing them. My goal, as much as possible, is to make technology that's very highly reliable, that's redundant, and that is really easy for people to know how to touch it and fix it if and when it goes down.
All right. So this is a little bit more technical question, which I think is interesting. You're talking about the L2 level of vehicles becoming sort of like L4 vehicle by restricting or simplifying the ODD. And I'm not sure whether that's enough. This is from the question. L2 systems are only safe because they have continuous human oversight. And they are not designed to be safe without human oversight. So there is a need for OEMs to do something more than what they have done so far for your solution. And then we want you to comment on that.
I mean, L2 systems as they are defined today by SAE, that's correct. And I was talking to one of the chief engineers at an OEM, a big OEM, just a couple nights ago, and he said something I thought was really wise. He said, I want to get out of the business of talking about SAE levels, and I want to get into the business of talking about the product experience that we're providing. Because I think when you narrowly sit and you say an L2 vehicle can be driverless, like, that's an oxymoron. And I totally get it, and I get that it's confusing. But let's talk about a vehicle that has lane keep assist, that has adaptive cruise control, that has a high reliability connection to infrastructure, that's driving in a simplified lane. At that point, then I think we're talking about a product experience for a customer that can be that driverless experience in those conditions. And I think that's right, what the question is commenting on, which is that has to be done in great partnership with the automakers and in great partnership with us. And that's why we meet weekly and monthly with a lot of our different OEM partners to make sure that collaboration is very, very healthy. And that's why I mentioned, when you want a world that has these smart roads of the future, you have to bring together the DOTs, the policymakers, the tech people, and the auto and AV. You've got to bring that together. And that's the great superpower that I think Cavenu has with the team we're putting together.
Yeah, I totally agree. I think whether it's L2 or L4, a vehicle in the future could be L2 and could be L4, and
right.
It's depending.
And it could be one vehicle.
Yeah, it could be one vehicle, and depend about the really driving environment.
Exactly.
Where it is. And I think we only have 1 minute, but I do want to ask you another question, sort of related to the
Totally.
last question the people asked. This question say, CAV connect automated vehicles feels like a case in which the technology is a bit ahead of consumer demand.
Yeah.
And what role do you see for Cavenu in educating and the driving public and providing more confidence on these technologies?
Yeah, I think it's interesting, depending on which audience I'm talking to, there are some that are like, wow, you're way ahead. And there are some that are like, wow, you're way behind. So the truth is probably that we're somewhere in the middle and maybe we're in the right spot. But I think that we're definitely at the breakthrough. Like I showed you with the data on how many cars are really coming to market over the next couple of years that have the technology already on board to be able to take benefit from a connected vehicle infrastructure system. And I don't think that that was true 3 to 5 years ago. It's really this moment right now. And so capitalizing on that, and then capitalizing on the fact that the federal government is recognizing the infrastructure is crumbling and we need to do something. And if you can put those two things together and you can build the roads and you can build them once and you can build them for the demand that exists today, but they're future-proofed so that the platform is already there, so that over time you can add more technology and you can be able to continue to make the roads smarter and more connected with the vehicles. I think that just gives everybody the preference that they want. And I think over time, the preference that people want goes back to they want safer roads, they want to reliably get from point A to point B, and they want to not have to have their mind on the driving task when the driving task bluntly sucks. So.
Thank you, Jamie, so much for taking time out of your business, your busy schedule, and that's all the time we have. And I still see a number of questions out there, but I don't think we have time to talk about these. Thank you so much for taking the time to give us the lecture. And I think for the audience online, if you miss part of the lecture, you can always check it out from our YouTube channel, which will be there next Monday. And you can also get notified when the video is uploaded online. And thank you very much. And thank you for everyone to participate for this lecture. Thank you.
Great. Thank you so much.